We're going to take a look at the quiz prep for 2-1 and 2-2. This is going to go again pretty fast through these quiz preps, so please stop and pause it if you need to. In number 1, we're going to subtract 4 from both sides. Negative 3x equals 12 divided by negative 3, and x is equal to negative 4. In part B, the distributive property here, so 4x, be careful with the negative. Negative 2x times 3 is negative 6. Negative 2 times negative x is positive 2x equals 6x plus 4. Some like terms on the left-hand side here. 4x plus 2x gives me 6x minus 6 equals 6x plus 4. Subtract 6x, subtract 6x. Negative 6 is equal to 4. Don't just leave it that way. Negative 6 does not equal 4. This is no solution. Those happen. Okay, we're in Algebra 2 now. We can have problems that don't come out as nice as we want them to. Part C, distributive property 2x plus 6 equals negative 3x minus 14. Move the smaller x, so add 3x. 5x plus 6 equals negative 14. Nice friendly equation. 5x equals negative 20. Divide by 5, and x is negative 4. Part D, distributive property 4x minus 4 equals 3x minus 4 plus x. 4x minus 4 equals, combine like terms, 3x plus 1x is 4x minus 4, subtract 4x. Negative 4 equals negative 4. Negative 4 does not have a variable with it on either side of the equation, so I'm not dividing by negative 4 here. I get negative 4 is equal to negative 4. That's true. Negative 4 does equal negative 4. Okay, so then this actually is all solutions. I can take any number that I want to and plug it into that equation, and it'll come out and give me an answer. Solving graph, so I want to solve this. Subtract 2 from both sides. X is greater than 5 minus 2 is 3, so I want to graph it. I need 3. I need a number bigger than that and a number smaller than that. Any number will be just fine. I have x is greater than 3, so that's an open circle. And I want the numbers that are bigger than 3. So the numbers that are bigger than 3 go over here to the right. Part B, subtract 6 from both sides. Negative 3x less than or equal to 3. Divide by negative 3. When I divide by a negative, the inequality has to switch. 3 divided by negative 3 is negative 1. So I have negative 1. I have a number that's bigger than that and a number that's smaller than that. Greater than or equal to is a closed circle. Numbers that are, I'm looking for my answer to be the numbers that are bigger than negative 1. So that's going to go over here to the right again. Part C. So I've got x's on both sides, so I want them to be on one side. So I've got 6 less than or equal to 2x plus 10. Subtract 10 from both sides. Negative 4 less than 2x. Divide by 2. Even though I end up with a negative answer here, I did not divide by a negative, so the inequality does not switch. However, most of us like the x to be on the left-hand side, so the x is getting eaten by the inequality, and so it still needs to be eaten by the inequality. So I have negative 2. A number that's bigger than that is negative 1, and a number that's smaller is negative 3. If you put those numbers in the wrong place, you will probably get this answer wrong. So I want bigger than with no equal to, so that's an open circle. Numbers that are bigger than negative 2 are going to go to the right here. Last one on this section, that's a negative 1 in front, so I get 4. Then negative 1 times x is negative 1x. Negative 1 times 3 is negative 3. Greater than or equal to 2. Even though I multiplied by a negative, I didn't multiply both sides by a negative, and so the inequality doesn't switch. Like terms on this side, 4 minus 3 is 1, so that's a positive 1, greater than or equal to 2. Subtract 1 from both sides, negative 1x greater than or equal to 1. Divide by negative 1 on both sides, so the inequality switches, and I get x is less than or equal to negative 1. So I have negative 1 over here. A number that's bigger than that is 0. A number that's smaller than that is negative 2. Closed circle, because it's got an equal to symbol on it. I want the numbers that are less than negative 1, and so my arrow is going to go this way. Need to have all those different parts for all those inequality problems in order for them to be correct. On the second page, we're looking at proportions. Remember, there's a couple different ways that you can do the proportions. The way that seemed for most of us to work the best is to cross multiply. So x times 13 is 13x, 3 times 8 on the right hand side. So I get 13x equals 8 times 3 is 24. Divide by 13, and x is equal to 24 over 13. We don't need to turn that into a decimal. It doesn't reduce, so that's perfectly fine. On the next one here, I'm going to multiply 4 times 9. X times 1 is 1x. 9 times 4 is 36 is equal to 1x. I don't need to divide by that 1 because that's what I'm looking for. I'm looking for what does 1x equal. 1x is equal to 36. Part C, when I go through 3 times 12 equals 9 times x plus 1. That x plus 1 has got to go in parentheses. So that 3 times 12 is 36, and then distributive property over here on the right-hand side. Nice friendly equation. 27 is equal to 9x, divide by 9, and x is equal to 3. Be careful with the negatives on this one, so I have negative 3 times x plus 1. The x plus 1 is going to go in parentheses, and then 5 times x minus 23. That x minus 23 goes in parentheses. Distributive property, negative 3x minus 3 equals distributive property. 5x minus 5 times 3 is 15. 5 times 2 is 10. Plus 1 is 11. X is on both sides. Move the smaller one, so I'm going to add 3x. So negative 3 is equal to 8x minus 115. Add 115 in this nice friendly equation. I get 112 is equal to 8x. Divide by 8. And I get that x is equal to 112 divided by 8. 8 goes into 11 one time. With 3 left over, 8 goes into 32 4 times. So I get x equals 14. Or you can plug it in the calculator. That'll work too. E, if a flagpole is 20 feet tall, so I have a flagpole over here. Let's draw a nice flagpole. It's 20 feet tall. Cast a 6-foot shadow. So I've got a shadow down here that's 6 feet. Let's say the shadow is going this way, like that. How long a shadow would a building that is 15 feet tall? So I've got a building here with some nice office windows that is 15 feet tall. What kind of shadow would it cast on the same day? So that's what I want to know. How many feet would this cast? So when we're making up this problem, I've got 2 heights of buildings. I've got 2 shadows on, or 2 heights of things, 2 shadows on things. I'm going to make a nice proportion here. So I can either do 20 over 15 and 6 over x, or I can compare height to shadow. So 20 over 6 equals the height of the building, which is 15, over the shadow of the building, which is x. Now you can multiply 6 times 15, 20 times x. 6 times 15, 6 times 5 is 30. 6 plus 1 is 90, divided by 20x. Divided by 20. And the zeros are going to cancel out. I get 9 halves, which is 4.5, which should make sense that the flagpole is taller. It should have a taller shadow. The building is 15 feet. It has a 9 halves foot shadow. So this is 9 halves feet. If you do 9 actually divided by 2, this is 4.5 feet. So either this is fine, maybe 4.5 feet makes a little bit more sense to you. But either one of them are okay. That's the quiz that you're going to be taking, solving equations, inequalities, proportions, and so a couple word problems with those proportions as well.